Okay, graphing linear inequalities. Okay, we need graph paper. Now these are linear inequalities. It's similar to how you graph a line, except there's two different things you got to watch out for. Y is less than x minus 1. So this is like our equals. This thing here serves as the equals. Okay, I make a wall. If the y is by itself, we could do our MB labels. MB. Okay, so slope, y-intercept. Slope's 1 over 1, minus 1's the y-intercept. So on the y-axis, we go down 1, then we go up 1, forward 1. Okay, now you have to watch out. If you have the equals to line underneath your inequality, it's a solid line, okay? Now, if the equals sign is not there, it's a dashed line. Now, if it just says equals, then the line is all of the solutions for the specific inequality, but when there's a less than or greater than with it, one side has all the solutions, okay? Infinite amount of solutions, okay, but one side. So I pick a point on either side. It doesn't matter as long as it's not a line. Let's go 2, 2, okay? You can pick anything you want. 0, 0 probably is the easiest, but I'm just going to illustrate it. Any point you want. So I substitute 2 for y. Now don't put the 1 under the x, okay? Just put 1x minus 1. 1 times 2 minus 1. Now, you do your operations over here. 1 times 2 is 2. 2 minus 1 is 1. Now, is that true? Does the sign eat the bigger number? It's supposed to. No, it doesn't. That's false. So that means in addition to the 2, 2, any point I have over here is false. Any point on the other side of the line, then by process of elimination, is 2. Okay, so that contains all our solutions that are true. This is all the false. Okay, next one, y greater than or equal to 3x minus 2. Okay, MB can be applied because the y is isolated. Slope, y-intercept. So slope, you're going to have 3 over 1 and then minus 2. Don't put the 1 up there. It gets in the way when we have to do our test. Just put it over 1 here. So the y, you go down 2, then we go up 3, forward 1. Equals 2 lines there, so it's a regular straight line. Okay, now I pick a point. It could be on either side. It doesn't matter. I'll do 3, 3. So I substitute into the inequality. I substitute 3 for y and then 3 for x. Okay, 3 times 3 is 9. 9 minus 2 is 7. That's again false. So I'm not a good guesser, but that's okay. So false is that side. Any point, if that's false, any point over there is false. The lines, in addition, the line is your equals, and it also separates the true from the false. So the true is any point over there is true. Okay, next one, y greater than 2x minus 6. Y is by itself, MB. Slope, 2 over 1. The y-intercept is minus 6. So from the origin on the y-axis, there's your point. And we go up 2, forward 1. Now the line is not there, so we make the line dash, noting that every point on the line is not a solution this time. That we have to have it there though to separate the true from the false. We just make it dash. Okay, let's go 1, 1. It helps if you do a coordinate that has the same number for x and y, so you don't have to worry about mixing them up. So 1 for y, then we take 2 times 1 minus 6. 2 minus 6 is negative 4. Finally, I guessed right. That's your bigger number. That's true. So every point here is true. Every point here is false. The true side gets highlighted. Okay, next one. Y greater than negative 3x. So y is by itself m, and the b would be 0. Okay? So slope, y-intercept. So our slope's negative 3 over 1, but the y-intercept 0. So this is my y, the y-intercept 0, and from there I would travel down 3 units and then 1 to the right. Or you can go right 1, down 3, it doesn't matter. Okay, every time x increases by 1, the y output goes down 3. And again, you can do it again. Okay, no equals to there, so the line is not part of the solution, but we still need it there, so we make it dashed. Okay, then I'll roll with 4, 4 this time. You can do any one you want. You could do 2, 3, 2. It doesn't have to be the same thing. I like to do it that way so I know I don't mix them up. So 4 greater than negative 3 times 4. Okay, we don't need to put the 0. So negative 3 times 4 is negative 12. So 4 is a bigger number. It opens up towards 4. That's true. So that point's true. That means every point on that side's true. Every point on this side's false. Okay, next one now. It's going to get a little more complicated. Now, you can't do your MB here. Okay, you want to write the equation so that you can. Here's what you need to do. First off, look at your y and its multiplier. That term is negative, okay? So we need to reverse the signs on everything here. And we reverse the inequality symbol. If we have to change the signs, we're multiplying it all by negative 1. When you multiply everything in an inequality by a negative, the sign flips. So it becomes positive 2, positive 3, less than negative 6. So rewrite that. 2x plus 3y less than or equal to negative 6. Now we can get into the process of getting my y by itself. So I would subtract 2x. Then I would make a 0x, so I have a place to subtract 2x. I line up my symbol, I have 3y. 0 minus 2 is negative 2x minus 6. Then we divide by 3. That is a decimal, so we want to keep that as a fraction because that's my m. That's 2 minus 2, that's my b. So now I've got my slope and my y-intercept. So slope is negative 2/3, right? Kind of small because you got to run the test still, minus 2. So I go down 2. And then from there I go down 2, 3 right. Okay, the equal symbol is there. That doesn't go away. If it's there at the beginning, it never goes away. So it's a solid line. And we'll do good old 0, 0. Okay, so I would do this. I would not go up here. I would do where I ended up at. So 0. Negative 2/3 times 0 minus 2. Anything times 0 is 0. 0 minus 2 is negative 2. 0 is bigger. It should open up towards 0. It doesn't, so it's false. So false, true, and there we go. So you want to make sure the y is by itself, but if your y is negative, yes, you are still going to change the signs, but you got to make your inequality the other direction. Next one, x minus y less than or equal to 3. Okay, I want slope y-intercept. Can't use that. The y, that's a negative, okay? So we need to change all the signs. So negative 1, positive 1, negative 3, and the inequality flips. So we now have negative 1x plus 1y greater than or equal to negative 3. Okay, now I'm ready to get the y by itself, so I kind of circle the y with its multiplier. We need to add 1x. We make a 0x over there and add 1x to that. So you got 1y, 0 plus 1 is 1x, and then minus your 3. So I divide by 1. Now it's not a decimal, so now you can write 1x over 1x, okay, minus 3. So we have our m, we have our b. So slope y-int. Slope's 1, 1 over 1, and then minus 3. So I go down 3, then up 1, forward 1, up 1, forward 1. The line is there, so it's a solid line, and I'll pick a point. Let's go with 1, 1, okay? So I put 1 in for y, and then 1 in for x. So 1 times 1 is 1. 1 minus 3 is negative 2. Eats a bigger number, that's true. So true, and you can just shade that side, okay? You're highlighting the side that's true. I'm not blacking it out, I'm highlighting. Okay, negative 2 plus y greater than or equal to 3. Again, the y is not by itself. We need to isolate it, okay? Well, at least the y is positive, okay? So I don't need to change the signs. That y is positive, no sign change, okay? No sign change. Do not go plus. You're not going to do that because that makes that a negative. We don't want that negative, okay? So if it is positive, we don't rewrite it, okay? And you don't change the sign either then, since I'm not doing anything. Then plus 2x, and make the 0x and add 2x there. So line your symbol up, you got y. You can put a 1 in front if you want, but it really doesn't change it. That's going to be 2x plus 3. Okay, now the y is by itself, and you have your MB. So slope, y-int. Slope's 2 over 1, y-intercept's 3. Up 2, forward 1, up 2, forward 1, okay? I would live off slope y-intercept here. So I'll go 1, 1. You can do anything you want. You can pick something over here if you want, but I like over here because it's easier to do with positives. 1 in for y, and then 2 times 1 plus 3. It's 2 plus 3 is 5. 5 is a bigger number, it's not opening to the 5, that would be false. Okay, so false, true. Okay, last one, 3x minus 5y less than 15. So your y is not by itself. First check your y, make sure it's positive in front of that. It's not. So negative, positive, negative, flip sign, okay? Now we can go into the process of getting the y by itself. So we'd add 3x. I'd make a 0x over there and add 3x. Remember, the sign has now been changed to greater than, and we have 5y. 0 plus 3x is 3x minus 15. So we divide everything then by 5. We have y. That's a decimal, so I leave it 3/5 x because that's my slope. Minus 3 is my b. So slope, y-intercept. Slope is 3/5. Y-intercept is minus 3. So 1, 2, 3. And from there I go up 3, forward 5. Yeah, you run out of room. You can just get 2. Dash line, because the equals was never there. And I'll go 1, 1. Okay. So 1 for y. Don't go up into the original. Go up where you left off. 1 greater than 3/5 times 1 minus 3. Okay, that was stupid. I should have, when you have a fraction, you probably want to do 0, 0, then times the 0. That might be the best idea. Times 1, 3/5, and I'm just going to subtract 3. Negative 2 and 2/5. Okay. So I timesed it by 1, then I subtracted 3. 1's bigger, positive 1's bigger than negative 2 and 2/5, so that is true. Because it opens up towards a bigger number. True, false. Alright guys, so I was saying on that. I hope it has been informative and you got these to do.